Hey guys, Pankaj here. Welcome back to my YouTube channel. So by now we have completed NumPy and Pandas video, and I think you will be very much familiar with like how NumPy and dimension array works, how Pandas data frame works, and what are various operation techniques, right? So now you'll be very excited to know like how to visualize the data once you have the raw data, correct? So today we are here to see data visualization using Matplotlib. Okay, so let me show my desktop and what and all I'm going to cover today. I'll show in the notebook. Okay, so here are the topics which I'm going to cover today in Matplotlib library. So for data visualization, believe me guys, Matplotlib is the best library so far in Python. And whatever other library also supports for data visualization, it has been derived from Matplotlib. So if you know how to use Matplotlib and all the support function, then you can easily work on any other advanced library. Okay, so after this, let's say we are going to talk about Seaborn, right? So which is also working on same principle and similar kind of functionality, whatever is supported by Matplotlib. Okay, so let's see what and all chart or plot I'm going to cover today. So we'll see basic plot like line, scatter, bubble, and bar chart with horizontal and vertical bar. How to plot stacked bar plot. Okay, how to put the label on the bar plot, and what is the technique for smoothing the line plot. Okay, how to plot histogram, pie, stem, lollipop, area plot, what is image plot, and what are various properties which we can modify in the plot. Also, we'll see how to draw horizontal or vertical line in the or inside the plot. Okay, how to write the text data in the middle of any plot, and subplotting and resizing plot size. And if time permits, then we'll see 3D plot as well as dual axis plot also today, or maybe in the next part of Matplotlib. Okay, so whenever you guys have any data or raw data, then first thing will come into picture or in your mind, like which kind of graph to be used for the given data. Okay, so I have already provided one difference link. This will be good for you guys to go through it. But yeah, whenever I plot something, then I'll tell you like you can use this plot for this kind of data. But to know more detail, I think I would suggest to visit this particular site and understand each and every plot, where exactly it is used, why to use, and how to plot them. All those things are explained properly here. Okay, so let's see the library, what and all I'm going to use. So I'm going to use NumPy as NP for creating the random data, and data frame in case you are going to plot with the feature wise or column wise in a given data frame. So we'll create a data frame based on NumPy random data. And matplotlib.pyplot is the library which we are going to use for plotting any data. Okay, so just remember this case sensitive matplotlib.pyplot as PLT. Okay, so let's see, code all the libraries. Let it load. Meanwhile, you can see here all the chart types are explained, when to use, where to use, what to avoid, what not to avoid. All the things are mentioned here. I think it is not loaded properly. Okay, so libraries are big, so it is taking some time. Okay, so it is loaded now. And after that, this line, I'll tell you why I'm using it, because right now we are using notebook, right? So in notebook, how you can create a plot within notebook itself. So for that, you need to, mostly this is enabled by default, but in case some guys are, some of you are not able to see the graph in the notebook itself, then you need to run this magic command, that is matplotlib inline. Okay, so let me run this. Okay, and if you don't run this, then it will normally open a pop-up, and in that pop-up window, all the graphs will be there. You need to close it manually, then again generate a new graph, which doesn't look good if you are working on Jupyter Notebook. So better you enable this line, percentage matplotlib inline. So it is going to plot all the graphs in the notebook itself. Okay, so now let's quickly create a graph. So guys, before plotting any graph, let me just show you a couple of things. So for any graph, what do you want basically? Okay, so you need, let me just annotate here. Okay, so basically for two-dimensional plot, right, what you are going to have, you are going to have X and Y, right? So this is your X axis and this is your Y axis, correct? So all the points will be mentioned here. Okay, for given x point, what is my y value? So this is basically, this x-axis is known as your independent variable. Okay, and this y is nothing but dependent variable, which is depending on x. So in x, I have some value, let's say 2. Okay, then for another point, I have, let's say 4. Okay, for another point, let's say I have 5. Okay, so like that, all the x point given y points will be there. And later you just plot those points and draw a line. Okay, so in case you are plotting a line, you can draw a line. In case you are plotting a stem plot, you can draw a vertical line. Okay, if it is a bar graph, then you will just have all the x and y point, and here all the bars will be mentioned. Okay, for the given x and y point, and so on. If you are having pie chart, then you will have basically a circle, and from circle, all the points will be derived. Okay, so what is one particular slice, different slice? It's kind of pizza slice, which is nothing but your pie chart. Okay, similarly, if you're going to have scatter plot, then again, so here x and y point, and all the points will be scattered together along with axis. Okay, so if you see in all the graphs, there is one common thing, which is nothing but for x and y points. Okay, so x in the given x-axis, what are the point, and for given x point, what is your value of y? Okay, so very important thing, only you need to have x and y coordinates, or x point and y points. For corresponding x point, what is your y point? That is what we are going to plot. Okay, so let me clear the graph now and show you. Okay, so that is what I'm just creating one x point. So x point is basically from 1 to, let's say I'm going to have 50 points, and I'm going to generate 50 data points. Okay, so let's say from 0 to, or maybe 1, 2, 3, 4 up to 50. And what is my y value? So y value, let's have a random number between 1 to 50. Okay, between 1 to 100, I'm going to have, let's say 50 random values. Okay, similarly, I'm just going to have y2 also for later use. Okay, so now it is created. Okay, so if you want to see x, this is my x point. Print y1, this is your y2 point, and print y2 is your y2 point. Okay, all are random. Now let's plot it. So first thing is, let's say basic plot is line plot. Okay, so for that we have used Matplotlib plot, PyPlot as PLT. Okay, so PLT dot plot. Now, if you take a look at the help of this, right, what it needs a lot of argument. So guys, this is all Matplotlib library, right? So in that library, it's about a lot of parameters. So each parameter, if you want to see, let me open Matplotlib library. Yes. So Matplotlib org. Okay, so if you go to documentation part, where is user guide tutorial? Okay, so you click on any of the plot and you will show all kind of supported parameter for each and every plot, and what and all values can be supported, and what and all value you need to provide while plotting it. Okay, so this is the best documentation from Matplotlib org. Okay, so you can just refer it and just watch. So first probably you'll see what and all I'm going to show you. Then you click on that particular graph and see what other points are supported. Okay, so line plot. So if you are getting confused about all those parameters, the best thing is, as I mentioned, every 2D plot needs x and y coordinates, right? So first you provide x and next is y, x comma y. Okay, if you do this plotting, what happens? Oh, sorry, I have given y1, right? Yeah. Okay, so it is going to take each and every x point, and for each corresponding x point, exactly y points are there. So those things also getting plotted. Like for x equal to 0, I have how much? Or x equal to 1, I have 48, and y2, I have 15, correct? So that's what is getting plotted. And for x equal to 2, y2 is nothing but 47. The same thing is getting shown here. So remember, by default, x ticks and y ticks is going to be uh, given in a particular range by Matplotlib library itself. If you want to modify, like if you want to see exact xticks, like right from 1 to 50, all the numbers, then we have something called plt.xticks, which I'll show under editing module, editing or modifying the graph properties. Okay, so let's go with the default first. So this is the default plot. I can enhance a couple of things here. So one is like plt.figure. It is a function. Under this, we have an argument called fixed size equal to, so just provide the resolution. I want 16 by 4. So 16 is your width and 4 is your height. Okay, so this will look better. Fixed size. Okay, so now it makes more sense to have bigger and wider plot to see all the data points. Otherwise, it will be a little dense, and if you are doing a lot of other property visualization, then this will be very confusing, and you will not be able to see the data points properly. So better go with some proper resolution, whichever is best suited for you. Okay, so after plotting, if you see Matplotlib lines 2D, right, it is giving some value, right? So because this generates one object, so to avoid this, what you can do, plt dot show. I don't want to see the object. Always show the plot. Okay, so this is your default with some value. Now let's go with some coloring. Okay, so plt.xy. Now I want some coloring. So if you see here, again, here it is not showing everything, but this star arcs and curve is nothing but your all the parameter whatever I'm going to use. Okay, so coloring, you can use C or color, or you can directly define like this. So I want red color. Just mention that. Not here. Okay. So instead of by default it is blue color, now it will show red color. Okay. Similarly, couple of other parameters. By default, if you are seeing the continuous line, I want to have dotted line and blue color. You can give this. Okay, so by default, this is line. Now I want to mention dot dot or hash hash. Not hash, basically dotted line. Okay, so this is a broken line. Okay, similarly, you can have, there are so many different options. So like I can have BH. So this is nothing but hexagon. Okay, H stands for hexagon. So all those things you can find under Matplotlib library. Okay, so I would say just dig through it and get to know all the options. Okay, and now if I want dash and dot. Okay, so you can see this kind of line. Okay, so this is about line plot. Now let's see how to smooth the line plot. So why this smoothing is required? Because if you see a lot of data point, right, it is just kind of zigzag plotted because of each point. So sharp turn is there, right? So if you want to convert that sharp turn into curved turn, then you have something called smoothing. So this kind of sharp you will not see. You can smoothen the curve like sine wave, how you see, right? So for that we have something called one special library is there. Import from scipy dot interpolation. So basically we are going to interpolate the data. Interpolation import p one dimension. Okay, so this is the library scipy interpolation. Let me check why it is not showing here. This library should be there. I don't know why it is not showing. So wait, I'm sharing wrong file. Okay. Oh, I think it is interpolate, not pollution. Did I mention pollution? Yeah. Interpolate, inter 1D. Okay. So what is exactly it does basically? We will get the minimum of x and maximum of x, and between that we'll create so many data points. Okay. And for each data point, we are going to interpolate the data. Okay. So let's say in between, though we have 50 points, I'm going to generate 600 points between 0 to 50. Okay, and for each 600 point, there will be interpolated y value, corresponding y value. Okay, and that is what we are going to plot. Okay, so let's see how to do that. So we have x equal to, or maybe x. First, let's plot the original value. Plt dot plot x comma y1. And here I'll mention plt dot figure is equal to 16 by 4. Okay, so we have already seen that. Plt dot show. Okay, now let's interpolate the data. So what I'll do before, after plotting this, I will just calculate x new data point equal to, so np dot, let's say linear space. So linearly spaced value will be created. Okay, so between x dot min and x dot max, and I want, let's say 400 points. Let's go with new, or maybe 300 points should be good enough. Okay, and this x new I'm going to provide to enter 1D. So let's say int equal to one PRD. What it needs x and y, right? So I have x and y one, which I have already given, and what else it needs? Kind is fine, but I'm not going to just give. Okay, we have linear, quadratic. Okay, let's go with quadratic. Okay, so I can show all the options. We have zero kind also. Okay. Okay, so now interpolate value object is created. This inter is nothing but it is going to create an object, and in this object I'm going to pass x new. So for each x new, it is going to create the new y1 value. Okay, that is interpolated value of 300. So I'm just going to use plt dot. So I have x new, and y new will be what? Your inter, in this you just mentioned x new. Okay, let's see that. Yeah. So it is going to create, as I mentioned, right, we have given 300 value, right? So between 0 to 50, it is going to create another 300 value, and it is going to interpolate the data. Okay, so let's see. First, I went with kind equal to 0. So there are 3 or 4 different kind of kinds. Okay, so I'll give inter1, or let's give inter2, and here I'm going to give linear. You'll see the significant change in the graph. Okay, so inter3, here we have one more thing called quadratic, the best one for smoothing the curve. Okay, and let's plot all of them. So this one is nothing but inter 2 and this one is inter 3. Okay. So what is the problem here? Linear, sorry. There. Okay, so let's plot each graph with different colors, then it will make more sense. So I'm going to original or 0 equal to magenta with dotted line. And this one I'm going to plot with, let's say, blue color with dot. And this one magenta color or maybe black color with dot. Okay. Yeah. So quadratic is this one, right? First, I'll show the basic difference. Let's plot with this. So instead of 0, I'm just going to create quadratic, and this is a third one. Okay. So now you see how beautifully it is interpolating the data. And instead of dot, you just plot with this line. Okay. So you see this sharp turn. Wherever you see sharpness, you see it is smoothen the curve. Okay, by using quadratic, it is applying quadratic equation and getting the more clear data. But here it will go with the zero method and linear method. Okay, different equations are there. Accordingly, it will modify the data. Okay, so best suitable is quadratic. You may use it in machine learning sometimes for data visualization. Okay, so that's about smoothing the curve. Now let's go with the scatter plot. So for scatter, we have plt dot scatter. So whatever name you give, right, the same name that function is existing. So again, for this is also 2D plot. So we need X point and Y point. Okay. This is Y1. Okay, plt dot show. Again, I'll make plt dot figure X size equal to 16 by 4. Okay, so this is your default scatter plot. If you want to change the color, then we have something called C or color. Maybe let's take a look. Yeah, sometimes C also work in some graphs, sometimes color doesn't work. Okay, so you can just give it a try. Similarly, you have so a lot of other parameters also there. So we have X, Y, then S stands for size, C stands for color, and what is the marker, right? So marker, you can give different kind of markers. Okay, then we min and max accordingly, whichever you want. Okay, so edge color. So whatever points are getting plotted, what edge color you want. So edge color can also be different. So let me just try one. So I want edge color of, let's say, black. You see here, for each red point, it is black edge, correct? So this is about scatter color. So scatter plot. Scatter plot will be used for whenever you want to see how my data is distributed. Okay, so for distribution related stuff, scatter plot will be used. And if you want to use some kind of trend, how my trend is there for given data, you will go with the line plot. Okay, so the best thing about the scatter plot is you can convert a given scatter as bubble plot. Okay, so let's see this very interesting one, and this is my favorite graph. Okay, so how to plot the size? So we have something called, let me remove edge color here, and I'll go with blue. Okay, so you see here for each given point, size of the point is same, right? But what if you have, let's say, some value, some data points for Y is more, some data point is less, right? So accordingly, you want to plot the size of that bubble, okay, or size of that point, right? So we have something called size equal to, let's say I'm just giving some factor by 20. Okay, so what will happen? Okay, so this is your 20, and if I give 200, okay, so accordingly, the whole point is getting 200 size, correct? So how to make the size variation? So for that, you need to go with the for loop. So what I'll do using for let's say I, that is nothing but index range. So whatever is the length of y1 data, I'm going to iterate over each point based on the length of y. Okay. So once I go there, I'll just take, since I'm getting the index, right? So I'll take index of x idx and y1 idx and plot them accordingly. But again, I cannot use the same size. So what I'll do, since it is plotting circle, right? So runtime, I can generate the different sizes of circle. Okay. So let's put the area of circle. So what is that? Pi r square, right? So pi, either you can hard code or you can give, sorry, 3.14, or you can use np dot pi. Okay. Multiply by r. So let's treat this value of y as radius of circle. Okay. So I can give y1 idx and star 2, that is square of radius. Okay. So now if you do this, see, it is going to plot a different size of circle. Okay, so seems like it is too big based on the given data point. So we will multiply this factor with very small value, some fraction of value, let's say 0.3 star. Okay, still it is big. So what I'll do, I'll just reduce to 0.03. Sorry, 0.03 I mentioned. Yeah, this is much better. Okay, so that's how you calculate the size of a circle. Maybe I'll just give it to see a little more. Okay, so this is better. So now if you see, a couple of data points are overlapping with some other data point, right? So in this case, what happened, even though your value might be slightly different between each overlap point, so it makes sense to create a transparency between those points. Okay, so that each data can be visualized. Okay, so maybe what there is some point which is smaller than this. So this is like completely hidden, right? So in this case, we have something called, to control transparency, we have something called alpha value. Okay, so alpha is for transparency control, and this value between 0 to 1. So by default it is 1. That's why you see everything is same color, right? So I can give ALPHA equal to, so 0 stands for minimum and 0 to 0.9 is the maximum. Okay, that is 1 is maximum. So let's say I give 0.2. Now see, it makes a little, I think this makes sense, right? So you see here, a lot of data points are almost very, very close to each other. That's why you see all are getting overlapped, right? And it was not visible in previous case. You see here, correct? So if you control the transparency, then this will make sense. And this kind of plot will give you exactly how my data is distributed. Where is my cluster of data? Okay, so let's say so many points are getting overlapped here. You can easily catch my whole data is concentrated on this area. My whole data is concentrated on this area just by looking at this transparency. Okay, so that's about bubble chart. Now let's see next is bar plot. So bar plot you can basically use for whenever you want to have some kind of category values, and each category having so many values, right? So what kind of count is supported, or what kind of count is existing for a given particular category or feature. Okay, so for this we have something called plt.bar x comma y1. Okay, let's plot it and see. Okay, plt dot. So plotting in Matplotlib is very, very easy. Okay, so all you need to do is just run exactly once, and you will understand what kind of bar, what kind of plots are existing, and each plot how you can control it. Okay, so this is your bar plot. Okay, so by default, if you are plotting bar plot, it will be vertical. Okay, so to plot horizontal bar plot, you have something called bar h. Okay, so whichever best needed for your project, you can use whatever you want. Okay, now let's talk about stacked bar plot. So why stacking is required? Well, let's say you have multiple data points or multiple features, and each feature you would like to plot over each other, right? So that's where bar will come into picture, stack bar plot will come into picture. Okay, so how you can do that? plt dot bar, then x dot y1, so y2, okay. So if you are plotting multiple things in single line, right, so that's how your plot will look like, but this is not correct. Though it looks like stack, but this is not correct. Why? Because see, addition of those two are not 100%. If you take a look at this bar, right, so first your orange bar plot has been plotted, and behind that blue bar plot has been plotted. But you see here, whatever is uh, transparent, not transparent, basically whatever is visible, it doesn't mean that your bar plot ends here. This might be coming till here, or till here. You don't know, right? If you control the width, then you'll get to know, correct? So if I control the width, let me show you the difference. Yeah. See here, this is orange plot. And if you take out this line, right, your blue line is not just, from here, it is coming behind this also. Okay. But in case of real stack bar plot, your blue line will exactly start on top of this. Okay. So it will be, kind of 100%, and based on 100%, how much is blue and how much is your orange data. Okay. So how to do that? You have something called x1, xy1 width, and xy2. And here we have something called bottom. At bottom side, I want y1 data. And let's remove this width. This I don't need. Okay. Now you see the difference. This bar and this bar. Okay. So this is your actual bar plot, stack bar plot. So in this kind of stack bar plot, your complete data will be shown in the stack manner. Okay. So here your blue data is also like y1, and this is your y2. Okay. So now you got the plot, and later you can just do the labeling also, right? So how labeling will work? Let's plot that also. So label means like what is the value of this orange, what is the value of this blue. Okay. So first I'll go with this particular graph. Okay, so for label, basically you have to iterate over each value of y1, and accordingly you put the text on that particular bar. Okay, so for that, again, I'm going to use for idx in range length of y1. Okay, so plt dot bar, then for this idx, what is my x value? And for this idx, what is my y1 value? Okay, so it is going to plot, since we are iterating for each data point and we are just plotting without any color, so Matplotlib will automatically choose the color for each and every bar. Okay, so let's see here. You see. Okay, so if you define the color, then every graph, every bar will be of same color. Okay, so how you can do that? I can just choose color equal to, let's say, red. Okay, so this makes more sense, because otherwise you will think, okay, this is different data and from different data, different bar from different data points, but it is coming from same data points. Okay, so from same data points, you always plot the same color. That's what we have used here. That is red. Okay, now coming to the next point, that is how to give the label of that. So for labeling, we have something called plt.text. Okay, so this text function needs at what x and y position, what text you want or what string you want to put. So, okay, so this is my x position and this is my y position. At this x and y, I want to put y value, because bar is nothing but you're representing the y data, correct? I can just put this. Now let's see the graph. Okay. So for each bar, I'm just getting their corresponding values also. So if you want to arrange a little bit left, right, and center, you can play around with the X and Y value. Okay, so let's say each value is shifted little bit right. I can just put maybe X by minus 0.25. Let's see. You see it. Okay, so this is the original data, and right after shifting, you see values are little shifted. Correct. And if it is touching the graph, what you can do, you can just shift the Y position also, plus 0.3. So everything will be shifted little bit up. So I think point is too less. So what I'll do, I'll just make it little more, 0.8. Okay, some value you see it is shifted. Okay, so that's how you control the labeling and shifting left and right based on the text. Okay, and this function is common across all the graph. Wherever you want to do some labeling, use plt.text. It always needs what is my X position and what Y position and what string you want to put that X, Y position. Okay, now let's see the histogram. So histogram is what I think in the previous class I have already talked in pandas class. Histogram is nothing but it provides the frequency of occurrences of a particular value in the given data set. Okay, so I have, let's say, y1, right? So in y1 you will see a couple of values are coming 2 or 3 different time, right? So what I will do, I'll just take the same data set. Let's generate new one. Okay, then you will understand what I'm talking. So x, let it be like this, and y1 is nothing but, let's say I have 100 will be too much. So what I'll do, I'll just take 50 value and I'm just going to generate 100. Okay, so between 1 to 50 I'm just going to generate 100 different values. So definitely you will have some repetition, right? So y2 is not required. So let's plot the histogram. So plt.hist, you just need to provide the y1. Okay, so what it will do, it will just find what value repeated how many times, right? So exact count will be there, and each count will be just plotted here. So like 0 to 10, I have some value which is coming these many times, right? So how these beans are getting selected? So beans by default is set as none. Okay, so what I can do, I know I have 50 values. So out of 50, I can generate, let's go with default. Then I'll go with, let's control the width of these bars also so that you can see separate bars. Okay, so we have something called r width equal to 0.8. One is like very close, 0.8 will be less. Okay, now it is better. And I want to control bin size as, let's say 50 bins. I think 50 will be too much, we'll control it. So out of 50, let's say I want to have 10 bins. So the moment you give 10 bins, right? So I'll have like 0 to 1. How many such numbers are there? 1 to 2, 2 to 3, like that, up to 10 bins. Okay. So each number will be counted and that bar will be plotted. Oh, sorry, 50 values are there. So 0, 10, 10 to 20, 20, 30, 30, 40, 50, 50. Okay, so that's how it is shown here. So you can control some other parameter as well. So we have bins, then we have range. You can also give what is density, weights. These things you'll understand once I talk about statistics. Okay, his type is bar. Then we have, I think, ladder or something. So let's see this. Alignment by default, it is mid. Okay, you can control left and right as well. Color also you can control. So color you can give like this. Okay, what I wanted to show, I think. Not orientation. His type. Okay, so let's see what is his type here. Yeah, we have bar stacked, step, and step filled. Okay, so let's control this as step. Based on your need, you can choose whatever type you want. Okay, so this is what step, and step filled is also there. Okay, this is exactly same as step, but it is just filled. Okay, now this is about histogram. So I suggest go with the basic. Then whenever you need some more data, explore each and every option, see what and all parameter it takes, and accordingly you play and get your work done. Okay. Now let's see the pie graph. So pie is nothing but it is kind of, let's assume that is a pizza slice. Okay, each slice, what is their size and what is their label, how much percentage is contributed. Okay. So this will be definitely a circular plot. So I'll just take y value. Let's say I have 2, then 4, then 7, 3, 9, 4, 4, 6, 2, 9. So how many values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values are there, right? Okay, so all you can do plt dot py, then just use y. Okay, so each value based on their number of count, number of occurrences, it has taken the slice, and accordingly that size has been generated. Let's say you have 9 multiple times. See what is happening. So whichever value is representing 9, that label will be little more. Okay, so this is with the default data, and now I'm just going to remove this 9 multiple 9s. Okay. Now let's put the data label. Okay, so for that we have something called label here. Labels, correct? So what labels we have, whatever y you have, exactly you just give the value. Okay, so for each slice it is going to put the label as well. So for 9, 4, 4, whatever values are there. Okay, now we have something called, let's beautify this pie chart a little more. So we can control the shadow as well as uh, and explode also, right? So we have shadow, it is boolean true or false. So let's make it true. You'll see shadow, some kind of 3D effect. Okay, now you can see at the edge side. Okay, you can control the angle also. We have another thing which is explode. This is very important part. So explode, like how the slice should be coming out of the center. Okay, so we just put all the numbers. So we have 10 values are there. So if you give 0, 0, 0, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So by default it is 0, 0 degree explode, right? So I'm going to give some value, and accordingly it is going to be exploded. So let's say ninth value I want to explode by 0.9 degree, 0.8. You see here. Okay, so that's how you can control each and every slice accordingly based on your need. Okay. Now, similarly, I want third slice, 0.8 is too much. So what I'll do, I'll just control 0.2. And third slice, I want to make is 0.3. So it will be a little more. Okay, so based on your need, you guys can do that. Similarly, we have one more thing called center. Let me just see. I think you can control center or some kind of angle. Let me just take a look once. So using that particular point, you can control like where your label should be present. Will it be outside or will it be inside? Okay, so center 1, 2, we can give label distance. Yeah, label distance we can give. So this will be, let's say, 0.2, 0.2, X and Y. Is it 0.2, 0.2 or what? From center, how much it is? Yeah. So this is not this. From center, I can have 0.2. Okay, so you see the value from center, it is 0.2. It is basically distance, right? So 100% or 20% distance it has taken from center to outer orbit. Okay, so if you give 0.5 exactly at the center of each slice, it will be present. Okay, so various parameters. So I would suggest please play with that and understand how it works, and accordingly you can use it. Now let's see the stem plot. So stem plot is nothing but it is just going to provide a vertical bar. On vertical bar, it is going to print the show the point of that y data. So plt dot stem. Let me take the same value here. Okay, so where it is. Okay, so it needs x and y1. Could not broadcast. Okay, did I modify the value? Okay, so plt dot stem, it needs x. Looks like this line is still running. Let me interrupt it. Okay, so stem needs x and y. Let me plot this first one and see it is working or not. Yeah, it should work. P dot show. Yeah. Okay, so I don't think so it will be very helpful data or very helpful graph, but yeah, in case you need to plot something, then you can use stem as well. Okay, then lollipop is nothing but create your bubble chart and mix with the stem. That's what is your lollipop. Okay, so what we can do, we can just use this. So these are stem for IDX in range length of y1 plt dot capture x of IDX and y1 of IDX. Okay, and s equal to 3.14 star y1 dx star 2. Let's plot this. Okay, seems to be very big, so I'll just multiply with some factor 0.3. Like this. Okay, that is your lollipop plot. Okay, it looks like lollipop. That's why it is called lollipop plot. There's no direct function for plotting this particular graph. It is just mix of scatter as well as stem. Okay, now let's go to area plot. Area plot is nothing but exactly it is your, consider it as line plot, and below line whatever area you see it is going to be filled. That is what is your area plot. So let's take this number plt dot plot x dot y. Okay, so what I can do, filled area. Why it is not filling it? Because we have to give fill between, not filled area. Okay, so fill between x and y1, whatever is coming, filled. It fill between. Yeah. plt dot show. Okay, so this simple graph, just you need to fill the data or automatically it will get filled between x and y point. That's all. Okay, so color, of course, all remain same. You can just choose it. What other parameter you have, x and y1, where interpolate, step. Yeah, those things not required. Let's go with default. Okay, so color. Yeah, those things are common parameters. It is going to work. Okay, so mixed plot is nothing but so in the notebook, right? If you keep plotting graphs, right? So every graph is going to be plotted in the same figure. So in that figure, you can plot a number of plots. Okay, so let's say I'm plotting along with a scatter, I'm plotting line as well as dotted line, lot of plots, right? So everything will get mixed and you'll get the mixed plot. So what I can do, plt dot plot x comma y1, and I can have plt dot bar to say 0.2. So why it is not working? Fail to convert value to x is 0. plt dot bar. Okay. Yeah. So it is kind of bridge. Now I can have plt dot stem as well. So for stem width might not be applicable, so you can just remove it. Okay, similarly, I can have plt dot scatter. Width is not required, but I can go with color equal to. Okay, so I think it is getting overlapped. That is the problem. Okay, so I can give size equal to, let's say, 200, and it will be visible. Correct? Yeah. So what else you can have? You can. Yeah, I think you have created line, bar, stem, scatter. That should be good enough. So this is called mixed plot. So in single plot, you can have multiple plots. So we'll see how you can plot different plots in the different way by visualizing in a different way. So for that you have to have subplot. So we'll see subplot maybe today or maybe tomorrow or in the next video. Okay. So yeah, this is about mixed plot. Now let's see the contour plot. What is contour plot? So plt dot. So contour is nothing but, if you see, right, for terrain visualization, they mostly go with contour plot. So how it works basically, you will have a lot of circle in and around, and whichever points are very close or maybe very dense, that is nothing but representing the peak of the mountain. Okay, as you go far away from the peak, you will see line is getting spread, And that's how your control plot is plotted. Okay, so I'm going to generate x equal to np dot random, or maybe in -2 to 2 and 0.25 is my x point, this is my y point. This you give, let's say 3 to 3. Okay, and for plotting contour you need to have something called mesh grid. There is another function called mesh grid, so using that only you can plot the grid. Okay, so what I'll do for that, I'll have x and y. Mesh grid is nothing but, let's say you have a 4 by 4 square. For each point, each small square within 4 by 4, you are going to have x and y coordinates. Okay, so that's what np mesh grid would do. Np dot mesh grid, it needs between x and y. So I can just show how it looks. So these are x, and for each x and x, there will be y point. Okay, so z will be nothing but your contour plot. So what we can do, we can put some kind of formula to create z point. Okay, so let me just take some ready-made formula here, and we'll see it works or not. So np dot sin x with some, I'm taking random value, square of 10, then cos, then take y value, multiply by x, then np cos x. Okay, that is your z. Okay, now you plot plt dot plot what it needs. Is it correct? Contour, right? Not contour plot, because it is already plt. What it needs? It needs arguments, right? So I want x and y and z. It is capital Z. Okay, this is your contour plot, and it is going to generate one object. So let's say CT is nothing but CP is contour plot, and after generating contour plot, I can put the labeling also, whatever Z points are there. So we have something called plt dot c label CP. Okay, plt dot show, then plt dot color map. If it is applicable, it will show the color map also, or C map. I don't know it is there or not. Let's have a look. So it is not color map, it is color bar. Color bar. Basically, it will represent the value of the dense the color, bigger the value. Okay, so you see here minus, and this is your the darker color, or lighter color means higher value, darker color is lower value. This is minus 1.2. Okay, so I think right now it may not make more sense, but just be aware contour plot is also used. So in case your project needs this, then probably this is a way to draw it. Okay, so let's see the next one, that is image plot. So image plot is nothing but basically it is used for heat mapping. Okay, so heat map, there are a lot of different way to generate it. I'll show in the Seaborn also, but let's see how to generate it quickly from Matplotlib. So I already have y points. Okay, so whenever you have NP array, what you can do, you can just generate it. Let me create a shape first. So y1 dot size, how many values are there? 50, right? So I'll just do y1 equal to y1 dot, let me make y2 reshape 5 by 5, 10, right? So let's have 10 rows, 5 columns, y2. Okay, so whenever you have two-dimensional array, you can easily generate that array or convert that array into image form, right? So for that you have plt dot imap or imshow. All it needs is your numpy array. Okay, so now you can see. Let me make it bigger. Plt dot, or what I'll do, I'll just take 5 rows, 10 columns. It will be much better. Okay, so this is your image show, and for each pixel. So why it is called image show? Because pixels are or images constituted by pixels, right? And each pixel will have different value or different grayscale or different color bar, right? So now what is my value for this pixel? How to do that? So what you can do for IDX or maybe X in range. So range I have X values are how much? 0 to 8, right? Or mostly 10, right? So I can give 10. And for each this, I have Y also. Y in range, let's have X and Y. I have total 5, right? Just give 5. Okay, so plt dot text. I want to put the label, correct? So what is my X position? I have X position as X. What is my Y position? That is Y. So for X 0, and what is Y position? That is this. And what is my value? So Y2 of X and Y2 of Y, because X row, Y column, right? Let's see it fits or not. Index 5 is out of bound, X is 0. Okay, so I think we just have to change it. Y to X. That's all. So Y value is nothing but your 0th row, okay, and X column, that is 0th column. Okay, similarly this and that, you can just plot all the values. Okay. So that's all about image show. This is more simplified in C1, so I'll just use from C1 only, heat map, and a lot of color options are provided. Okay. So you can have something called CMap also. Let's go default. There is something called CMap, and there are almost close to 100 or 200 different maps are there. So red and blue. If it is not there, then you can find out what is supported color. These are the color maps supported. Let's say I want to have red, yellow, and green, correct? So I can just copy and paste it here. Yeah. Okay, guys. So yeah, that's about image show. That is image plot or n-dimensional array plot. Okay, so I think this is good enough for today. It is too much. So let's complete tomorrow remaining things, like how to edit the property of different plots and how to do 3D plotting and how to use dual axis in the same plot. Okay, and how to save the graph or plot in the local disk. So that we'll see tomorrow. That will be very helpful. And tomorrow will be the end of Matplotlib. Okay, guys, so that's all from my side today. Thank you so much. Those who have not subscribed my channel, please do subscribe and like the videos. Feel free to give comment. I'm not getting comment from most of the guys. And if you are understanding, that is good. If you're not understanding, please give the comment. Okay, thank you. Bye-bye.